Reasoning to find area. We are going to focus on making a connection between finding the area of parallelograms to finding the area of triangles. Below are examples of how two copies of triangle M can be composed into three different parallelograms. M, the original triangle, was copied. The orange triangle represents the copy. They were joined together to form three different parallelograms. What does this say about the area? What connection can you make between the area of the parallelogram and the area of the triangle? We'll use this example. What is the area of triangle A? Explain how you know. A copy of triangle A is joined to the original in figure B along an edge to create a parallelogram. Because the two triangles have the same area, one copy of the triangle has half the area of that parallelogram. Hence, the formula for the area of a triangle is half the base times the height, or is half the area of the parallelogram. So let's determine our base and height. The base is 8. It's given. The height is 2. Substitute those into the formula. Multiply 8 times 2 and half of 16 gives me an area of 8 square units. Okay, we'll continue to practice. Figure C. This is our formula. Half the base times the height. We need to determine a base and a height for this figure. We'll determine that the base is 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I simply count it from one grid line to the next. You may prefer to count the spaces. I did not include the space that indicates that my height and base are perpendicular. Now I'm going to calculate a length for my height. 1, 2, 3. I substituted those values into my formula. My base was 10. My height is 3. That gives me 10 times 3, which is 30. Half of 30, 15 square units. Okay. You can practice on the next couple of examples. Just pause the video and then check your work. Okay. Now we are going to practice the second strategy that was introduced at the beginning of the video. Enclose each triangle in a quadrilateral or parallelogram with opposite sides congruent. Use the area of each quadrilateral to calculate the area of the original triangle. So what we're going to do is enclose each triangle into a parallelogram so their opposite sides are equal. Here we can simply copy. Here we can copy on figures A and C. On figure B, things will be slightly different. We'll have to copy twice. But we'll see what that looks like on the next screen. Okay, let's start with figure A. Figure A, we've enclosed the triangle into a rectangle, or we've made a copy and joined them along one side. We'll determine our base and our height. We'll reason that the area of a triangle is half the base times the height. Our formula, that gives us an area of 12 units squared. Figure B, it is enclosed in a parallelogram. And you should notice that we copied a triangle here as well as here, so that we maintain the same area. Our base and our height. Reasoning, the area of a triangle is half the base times the height. Half of 32, 16 square units. And C, our base and our height were determined after we made a copy. Our base is 6, our height is 4. 6 times 4 is 24, 12 square units. If you would like to practice some more, there is an interactive quiz on quizzes. Feel free to participate. Thank you.